Hi, everyone. Hope you're doing great. Technical issues happen, but we're here either way. So first of all, welcome again to another one of our XGeeks live streams on YouTube. First of all, it's awesome to see you all here because we've been growing our community and our reach lately. So welcome again. And if you're new to our YouTube channel and to our talks, we're happy to give you a brief introduction. XGeeks is a TI group company, so that works from Portugal and Germany. We actually have people in the two people and teams in the two locations. So we're an engineering company that is focused on providing capacity to product companies that are looking for challenge-driven product engineering. So actually, we're very oriented to solutions, and we build solutions through software. So it's quite exciting, our day-to-day. So if you're interested in knowing more about us, let us know and follow us on social media and all of that. And actually, I have a very special guest today to bring you, which is David, one of our very own software engineers. And David will give us a talk about Micro-Frontends with modular federations. But I think I'll give you the space and introduce to you David. And David, welcome aboard and welcome to our live streams. It's nice to have you here.
It's a pleasure.
Nice. I'll just give you the stage and give you the entire microphone. I hope everyone enjoys David's presentation and talk as much as I've been doing so far. So go ahead, take the stage. And just one small reminder, if you have any questions, everyone feel free to leave them in the chat. We're going to address them during the talk. So if you have them, feel free to leave them, and we're going to answer them throughout the presentation. So David, I think having all of this said, go ahead and break a leg. Thank you all. Enjoy.
Okay, so I hope my screen is being shared, right, for the presentation? Yeah, now it is. So like Rita said, I'm here to present to you today Micro-Frontends and how to leverage Webpack 5 together with Module Federation. And this is actually a sharing of an experience that we are having while doing this in a client of ours at XGeeks. So a really quick intro. My name is David Alecrim. I'm a senior software engineer at XGeeks, and I'll leave you here some of my contacts in order for you to get in touch with me after the presentation in case you want to reach out. So to get a bit of an introduction on Micro-Frontends historically, it was a concept first coined by ThoughtWorks. It was coined in November 2016, like you can see in the image. And it was introduced when they wanted to bring to their frontends the advantages that they were having in their microservice architecture. So it's being currently used by some big names like Spotify, Zalando, SoundCloud, Peasant, and it's quite a polemic subject, but like everything in our area, or many things in our area, it's a matter of fit, right? So there are scenarios where Micro-Frontends will fit, and there are scenarios where it won't fit. So it's a matter of pros, cons, and scenarios. You can see here some of the comments that I extracted from a Reddit post. So yeah, mainly it's bringing down the adoption of the Micro-Frontends. Don't use it because you don't have capacity. Don't use it because you have a small team. Don't use it because it brings complexity. Well, yeah, of course, but like I said, it depends on the problem, it depends on the institution, it depends on the team itself. So some of the main benefits that we wanted to bring to our clients from adopting Micro-Frontends were threefold, basically. It was to get more independent deployments between the different products that we have in the platform, to get less interdependency between them. And when I say interdependency, I mean interdependency even in development and not only in release cycles, right? And also to get better scaling, because the team is growing and it will keep growing even more. So with this Micro-Frontends model, we can better scale the different products inside the platform. To give you a bit of context, before I advance into the solution itself, I'm going to provide you some details of the client that we are working on. And before the actual situation, we were small teams. We were working in front-end, back-end, and infrastructure horizontal layers. What I mean by this is that the front-end team was spanning multiple products inside the platform, and one back-end team was spanning the backends across the different products that we have. Also, there was already around a 2-year cycle of development on top of the platform. So yeah, 2 years of experience is already a lot of code, as you can imagine. And then we have like a product vision change. So we wanted to do something more product centric. We wanted to focus more on product themselves instead of the platform as a whole. So inside our platform, we wanted to identify key products and we wanted to develop them. We wanted to give to these individual vertical teams its own product manager, their own designer team, depends. And this model would also scale better, like I told you before. So these vertical teams were what we wanted to achieve in order to get those 3 advantages that I talked about in the previous slide. So now that we know what we wanted to achieve, we started investigating, right? And MicroFrontends was a really clear answer to investigate. So we started the investigation on this. Basically, there are some frameworks for the MicroFrontends architecture. We have Mosaic 9, for example, which is the framework from Zalando. It was developed by them to implement the MicroFrontends in their platform. We have Single SPA, which is a really good one. They have a lot of documentation and best practices to use in the MicroFrontends architecture, and it's really cool. Then we have Pyral, and we have several others. But then we have another problem, right? Because like, if we adopt one of these frameworks, we are adopting another framework. We are putting another framework on top of that 2-year-old stack that we had. We needed to adapt the project. We needed to change folder structure. We needed to do changes in the code itself. And we really didn't want to do this. So we tried to investigate something that didn't use a framework already, right? So yeah, we wanted a no framework solution, and the conclusion and the answer to this is basically module federation. So module federation is bundled with Webpack 5. It was released officially on October last year, so it's recent still. And to quote the creator of module federation, I'm going to quote now, module federation allows a JavaScript application to dynamically load code from another application and in the process share dependencies. There's a space missing, sorry. So I'm going to take a bit on this and I'm going to expand on some ideas that this sentence has. So module federation allows a JavaScript application. By JavaScript application here, we mean that it needs to be a Webpack 5 bundled application. And then it allows to dynamically load code. So the load code part is really crucial. And what it means is that everything that Webpack can parse, we can share between different federated modules or micro-frontends. We're going to use this term interchangeably in this talk. It allows them to share dependence. It allows them to share code between them at runtime. And code means everything that Webpack can parse, like CSS files, JS files, React components, images, you name it. So everything that Webpack can parse, it can be shared at runtime between different micro-frontends. And in the process, they share dependencies. So this is also really key in module federation. And they have a lot of configuration to manage this, because one of the main pitfalls in a micro-frontends architecture is basically handling shared dependencies. Because when you have like one dependency in different versions in the same scope, in the browser scope, you may have like conflicts. It may break the experience. It may cause an unexpected behavior. So you really don't want that. And sometimes it's hard to manage this. So to expand a bit on how they manage shared dependencies, I'm showing this diagram. Let's imagine that we have 2 micro-frontends, micro-frontend A and B, and then the user lands on the micro-frontend A. So he's served the micro-frontend A experience. Then this micro frontend already has like 2 dependencies inside in the scope, React at version 17 and Lodash at version 4. Then the user navigates throughout the app and he reaches some kind of route. In this route, we need a component that is specified and is used in application B. So we request this component at runtime, like if it was an AJAX request for the code. Then what Module Federation does is he verifies what the dependencies are for this component. And he sees that component C depends on React version 17. We already have it in the scope, so it's cool. We don't need to do anything more. He sees that we need Lodash at v3. So what he does is he brings Lodash at version 3. And I'm being simplest here, but I'll be more thorough in the next slide. And then he also sees that we need date functions, and he also brings that into this scope. And what he does next is, okay, I have all the dependencies that the component that I needs. Sorry for the redundancy. And then it actually brings the component to work. So component C will be imported at runtime for the application A, and the user experience continues, and the user is happy. And he doesn't even know that a component was imported from another micro frontend. So yeah, this is how Module Federation shares dependencies really quick. One of the reasons that I said it was simplistic was because Lodash at 3.3 was imported here, but depending on your configuration, it may or may not be possible to import it. Yeah, and I'm going to show you a bit more on that a few slides later. So now that we knew what technology we wanted to use and what objective we wanted to achieve, how did we process this migration? Because we were in a monolithic application, right? We don't go from a monolith application into a micro frontends application from day to night, of course, night to day. So the plan was simple. So we had this architecture at the time, a monolithic application, a regular React single page application. The user would enter the experience, and then through client-side routing, he would be served different kinds of components. And what we wanted to do was to migrate to this architecture. So this is the desired architecture that we envisioned. It's basically the user always lands in a single entry point. This single entry point is the app shell. It serves as the only entry point that the user has. Then the app shell knows that there are more micro frontends in the system. So he knows that there's micro frontend A, B, and C, and he knows the location where they're at. Then when the user reaches some kind of base route, imagine he reaches /root A, as we can see here, then we import at runtime the code from that micro frontend, and we delegate everything else to that micro frontend. So that's the base architecture here. Each square that you see in this architecture is a micro frontend. Each one is deployed independently. Each one can be developed in a standalone mode. So that's also a really cool feature in this architecture, is that like if you're working in the team for micro frontend A, product A, you can work on it and launch the product, only the product A. You don't need to launch the whole architecture with the app shell, the application B, C, etc. So there's a way to actually develop this in standalone mode, which is good. So yeah, another really important and key feature in this architecture is that by providing this single entry point that we call app shell, we are actually providing the same user experience of a single page application, a regular single page application. Because when we import at runtime code from another micro frontend, that's exactly the same as doing code splitting in a regular SPA. So it's like making an AJAX request to the server and getting the response. So the experience is exactly the same, and that's really key because it's a really good experience in the end for the user. Another thing that we have here in the architecture is a shared lib. So this works as a shared micro frontend, in fact. And what it does is it holds all the common components for the architecture. So it holds the theme, it holds buttons, it holds text fields, it holds labels, everything that is common and that we don't want to declare in each of the products that we have, right? So we're not declaring the same button in the application A, B, and C. We're declaring it in the shared library. This has its pros and cons. We can talk about a bit more on that later, or if you have any questions on that, but we'll get to it. So now I want to show you where we are in the client. So because this is all an experience based on the client, right? We're still very basic in the migration. Basically, we have 2 micro frontends in production. The monolith was brought into a big micro frontend that has all the subroutes inside it through client-side navigation. And then we have also a shared library deployed with a shared micro frontend. And it holds precisely those components that I told you about, like the theme, the buttons, the labels, the text fields, all that stuff. So yeah, this is what we have in production right now. And what I want to show you is a demo of the implementation of the desired architecture. So all that stuff with the app shell, the different products, and the shared library. I'm going to show you a demo right now of how that looks like. So you can see the browser, yeah. This demo is available under my GitHub in a repository called Cloud Store MicroFrontends. In the end, you have a link to it, and we can also drop it in the chat, probably. I don't know if Rita can do that for me or not. Or I can do it. I'm not sure if the private chat is visible for everyone. So yeah, the code for the demo is in this repository, and we can see here the architecture part. And this is a more detailed implementation of the architecture that I showed you on the slides, but it's basically the same thing. So in this project, we have an app shell, the single entry point for the user, and the single and the only, not to stress enough this. It's exposed in port 3000. And then we have 3 different products. We have items, which are clothing items in this case. We have a checkout product and a blog product. So of course, well, probably this wouldn't be different products unless you were like a really, really, really big company. But let's imagine that you are, right? Because this wouldn't be adoptable for a small company either way. And yeah, the items are exposed in 3001. The checkout is exposed in 3002, the blog in the 3. And then we have our shared micro frontend, which is exposed at 3004.
David, we have a question. Sorry to interrupt you, but I think it's a good one.
Sure.
So first of all, Gerard, thank you for your question. So the question is, you may have multi-versions of the same dependency into the shared library. What are your thoughts on this?
Multi-versions in the shared library. Well, you can. It depends on how you manage it. And I think I missed a slide in this presentation that I had in another version. But what I wanted to show you is, and I can show you really quick. Let me just hit the code for the actual project, and it's easier that way. Open. Okay, sorry. Okay. Right. So I'm going to bring up an example of a configuration for the micro frontends, namely for the app shell. So this is it. I'm going to zoom in a bit so you guys can see better. Right, pretty sure that you can see now. This is the configuration that we have for the micro-frontend. It's basically the configuration for the Module Federation plugin because it's a Webpack 5 plugin. We have the name of it. So we know that this micro-frontend is called App Shell. These are the remotes. What this means is that this micro-frontend knows where the other micro-frontends are. He knows that they are located in 3001. The items, he knows that the other one is in 3002 at localhost, and so on. We also declare the manifest file that they have. So each micro-frontend needs to have a manifest file. And what this manifest file does is it states to the other micro-frontends what it has and what can be imported and what are the dependencies of the imported components. And then you reach the shared object. So this is part of the answer right now. So we are saying that we want all the dependencies in the versions that they are explicit in the package JSON. And then we treat two dependencies differently and in a special way. So we are saying that React and React DOM, for example, are singletons. What this means is Module Federation, when it brings a React to the scope, it will only bring one single instance. It won't be possible to have two different instances in the same scope. Module Federation won't allow it, and it will actually break. So this needs to be managed by the architect of the solution, and it needs to be enforced by the teams that are working on it. Of course, this is for critical libraries like React and React DOM. Let's imagine that you have Lodash. Probably Lodash v3 and v4 won't have like critical collisions. So yeah, you could have different versions of Lodash, for example, if one had one thing that you needed to keep and the new one had new features that you wanted to have. So I hope that answered the question. And now you know also how the shared object is configured for the Module Federation.
Great answer. Thank you, David, for that. And also thank you for the question. We actually have another question. So if you don't mind, I'll also pop that one. Is that okay?
Sure.
Nice. So this one is from Tiago. First of all, Tiago, thank you for your question. The question says, you said that we could develop the micro-frontend in a standalone mode, but if we have a shared micro-frontend that contains the common components, we probably need to run the micro-frontend and the shared one, right?
Yeah, so that's like the exception here. It does make sense to do it, of course. Probably if you are working on product A, you want to actually go and start product A or items in this case, and also the shared library because you are consuming stuff from it. So yeah, that makes sense, and you don't need to launch anything more in the solution. But it may be the case that you are not running a shared micro frontend, and yeah, in that case, you would only launch your product. But yeah, nice question, and yeah, it makes sense.
Cool. Thank you for the question, Tiago. Guys, just before David keeps with his presentation, just everyone remember that you can, of course, leave more questions in the chat. Okay, go ahead.
Okay, so like I was saying, we have here the diagram of the architecture that we have, and this is the actual demo of it implemented, right? So it's a very simple clothing store. It has a list of clothes. It has the details of one clothing item. It has a blog list. It has a blog post detail, and it has a checkout screen, and also a really small checkout component here in the top right in the nav bar. So I'm going to do a load of the first page, and we're going to see the network tab in the developer tools to actually get a bit more context on this. Also, it's in a fast 3G simulation in order for us to see the actual experience happening. So here in the top left, you can see a loading. It was quick, but I hope you saw it. That was the time between reaching out to different micro frontends that are deployed and bringing out the code and showing a loader between in that time. So you could choose to show nothing, or you could show like a really good looking spinner or something. So yeah, looking at the network tab here, we see here 4 manifest files, the remote entry.js files that I told you about. This manifest files, they are 4 because we have 5 micro-frontends in the solution, and we are reaching for the app shell, which is the entry point. So naturally, this single entry point will need to reach out to the different micro-frontends to get their manifest files. So this is what these remote entry JS files requests are. Then you see that we have a slash items here in the navbar. So we have a client side routing set up in the app shell. As I said in the presentation, the app shell knows the base route to each micro frontend. So the clothing items is in slash items, the blog is in slash blog, and the checkout is in slash checkout. Then every other subroute is delegated to the micro frontend itself. And we can see here that in this request. So we can see that we see the list of clothing items, right? And how did we do this? You can see here this request. We requested routes from 3001. So these are the routes of the clothing items micro frontend. We are requesting its routes. We are adding this to our scope. And now every time the user navigates inside it, so let's imagine that the user goes to the clothing item detail. So this route, the slash items, slash details, slash one, app shell doesn't know anything about this, and he doesn't need to know it. It's already delegated to the clothing items micro frontend, okay? You can also see that there are no more imports here in the network requests because we already have everything in scope that we need, for, at least for these 2 pages that come from the clothing items micro frontend. So we saw here that we can bring the whole experience of the micro frontend. So like get me everything from the micro frontend, and I built it into this scope, and now I delegate it to you. But we can also do more granular stuff. So this checkout item here, it's one really small component that is exported from the micro frontend. And we do this by stating this here. So I'm going to go to the item, the checkout micro frontend, which is somewhere here. And we're going to analyze the configuration file for the module federation. And we can see here a new key that we didn't see in the app shell, which is exposes. So what we are saying here for this micro frontend is that besides exporting the routes, or basically the whole micro frontend, right? Because we are then delegating it, the routes to it. We also export this really small checkout cart, which is the component that you see here in the top right. And you can actually see the request if I refresh the page. Sorry, I messed this up because I touched the name. You can actually see here this import checkout cart, and this is the import of that single component from that micro frontend, and only that. So if I add something to the cart, this gets updated as you would expect. And then if I actually hit a slash checkout here on the top bar, this is when the routes for that micro frontend are imported at runtime. So now the rest of the experience is already delegated to the micro frontend. And if I purchase the items, yeah, this gets done. If I go to the list, it's already there, everything. Everything is in scope, so no more requests are being done, like a regular SPA experience, right? We don't get hard refreshes anywhere. It's a regular SPA user experience. And then if we go to the blog, because we still haven't gone there, we can see a new loading because we are requesting the routes for another micro frontend. We can see here that we are requesting from 3003, which is the blog micro frontend. If we go to the details, this is already delegated, like in the clothing items. So this is the demo. There's nothing really much to show besides what I have shown. I hope you understand how this implements the architecture, and I hope I have explained good enough how we implement this architecture and the benefits that it brings. So yeah, I'm going back to the presentation. If you have any questions, feel free to drop them. I wrote 2 articles on this subject. You have here the links and the QR codes to them. The first article is basically the investigation and all the theory behind reaching the architecture that we want, which is the architecture that we have the demo for. And then the second one is the actual implementation. So all the steps in implementing the solution until we reach that demo that I just showed you. Then on the right, we have the code demos. The first one is the demo that I just showed you and the page with the repository there. And then we have this second one, which is the federated app shell. This is more like a playground where we are experiencing different stuff like state management in micro-frontends, like internationalization and other types of configuration when we initialize, per se, a micro-frontend. So yeah, we're kind of messing around with different stuff there. Feel free to see it, test it. Feel free to also do PRs if you want. That would be cool. So yeah, I encourage you to do some questions. Let's see if I can answer them. And also feel free to read the articles and go to the code, check it out, test it, see if it applies to your platform or to some other project that you want to test out.
Exactly. David, thank you so much for your talk. Just to remind everyone that if you have questions, David is still here, and this is a great opportunity to ask him for questions, comments, opinions. Feel free. Let's wait just 1 or 2 minutes to see if we have more questions popping by. But in the meantime, David, that was a great presentation. Thank you once again for that. That's always cool to hear from you.
If I hit something in this private chat, is it visible to the users, to the viewers? Sorry.
Not in the private chat, but I can share with them if you want to, and I would be happy to.
Okay, then I'll put it here, and if you can please share them, because they may not have had the time to copy it.
Mm-hmm. Actually, we already shared that one, so the link for the GitHub, so that's cool. So if you haven't checked it out, we'll share it again.
All right.
Wait. So I guess there aren't more questions yet, or from the audience at the moment. So we have Jean Souza saying, awesome. Jean Souza, I totally agree with you. Thank you for joining us for today. And thank you, everyone, but especially to David, that not only put this talk together and shared some of his expertise, but also to everyone at home watching us at the moment. Thank you all for being here. We'll have more of these talks. Alessandro also said that it was a great presentation. So I think this is a nice compliment. So, and we're happy to see you around in the next live stream, which will be next week. So see you there. And thank you, everyone, for being here. And especially thank you, David, for such a great presentation.
Thank you. It was a pleasure.
Nice. Thank you, everyone. Bye.